This question asks us to solve this system of linear equations, and in this video we're going to do this using substitution. There are other videos where I do this using matrix row reduction and elimination. So to use substitution, the first thing I'm going to do is to rewrite one of these as one of the variables equals. So in this case I'm going to go with z equals 5 minus 2x plus y. And then I'm going to take that, and if I just label these quickly so that we can refer back to them, I'm going to take that and I'm going to sub that into 2. So I get x plus y minus this whole thing, because that's z, is equal to 2. So that's x plus y minus 5 plus 2x minus y is equal to 2. So that's 3x. The y's cancel equals 7, or x is equal to 7/3. Now that's strange that we have got a value for x after only one substitution. That doesn't normally happen. We found a value of x, so let's see what happens if we sub that into something else. If we sub that now into 3, we're going to get 3 times 7/3 minus 3y plus 3z is this thing, 5 minus 2x plus y, and that's equal to 8. So we get 7 minus 3y plus 15 minus 6x. Oh, but 6x, let's not forget that x here is 7/3 plus 3y, which is equal to 8. So now I've got minus 3y and plus 3y cancel out. I've got 7 plus 15 is 22, minus 6 lots of 7/3 is minus 14, is equal to 8, which simplifies down to 8 is equal to 8. Now that is certainly true. And this differs slightly to the previous one, because in the previous example, we saw an example where there were no solutions. We ended up with one number equals a different number. And that's impossible, but this is not impossible. In fact, this is always true. It's always true that 8 is equal to 8. And what that means is that there are actually infinitely many solutions to the original equations. And what we know with those infinitely many solutions is that x is equal to 7/3. In all of those infinitely many solutions, x takes the value of 7/3. Now, whilst it is possible to go through this process and work this out using substitution, I find that most students find it difficult to make this final interpretation when you get to this result. It's difficult to see this and think, what does that mean, and interpret it to be the correct thing, that there are infinitely many solutions. This is why I recommend matrix row reduction, because matrix row reduction, there are very clear rules that tell you what each type of result means in terms of whether there is one solution, no solutions, or infinitely many solutions. With substitution and indeed elimination, it's a little bit more tricky to make that interpretation at the very end of the question.